Good morning, students. Today our trick is how to find the shape of the molecules. Trick for finding the shape of the molecule, students, based on the hybridization. Hybridization, already we know that sp hybridization, sp2 hybridization, sp3 hybridization and sp3d hybridization. Different hybridizations are there. Here look at the observed that sp hybridization based the examples, two examples I am taken here, BeCl2 and CO2. In the BeCl2, what is the central atom? Beryllium. In the BeCl2, what is the central atom? Beryllium. Beryllium group number is what? Beryllium group number is second A group element, valency electrons, 2 valency electrons. 2 valency electrons of beryllium. Around the beryllium, 2 chlorine atoms are present. The chlorine valency electron, the chlorine valency electron overlap with beryllium valency electron. So here, this is considered as S, this is considered as P. What is the hybridization now here? sp hybridization. sp hybridization means what is the shape of the molecule? Students, the shape of the molecule is linear. The shape of the molecule of BeCl2 is linear. Total pairs 2, bond pairs 2, lone pair 0. In that condition, the shape of the molecule is linear. Observe that second molecule CO2. What is the central atom here? Carbon dioxide. Central atom is carbon dioxide. Carbon dioxide, carbon group number, 4th A group element. Group number 4, valency electrons are 4. Around the carbon, 2 oxygens are present. In the bonding, each oxygen takes 2 electrons. Here the 2 electrons, another oxygen, here the 2 electrons. Now here overall, how many pairs are present here? This is one pair, this is another pair. This is considered as S, this is considered as P. So what is the hybridization here? sp hybridization. In the both molecules, total pairs 2, bond pairs 2, lone pair 0. In that condition, what is the shape of the molecule, students? Linear. Just look at the molecules here. Look at this. Just for suppose, this is considered as carbon. This is oxygen. This is oxygen. Here the oxygen, one is sigma bond, one is pi bond. Between carbon and oxygen, one is sigma bond, another one is pi bond. Here to this oxygen, one is sigma bond, another one is pi bond. One is existing in vertically, another one is existing horizontally. One bond, look at the observed here, this molecule. One is vertically existing, another one is horizontally existing, the pi bond. So in the CO2, between carbon and oxygen, double bond is present. Here the double bond is present. Hybridization is sp. The shape of the molecule is linear. The bond angle is here how much? 180 degrees separation. The bond angle is how much? 180 degrees separation. If you are observing the BeCl2, this is the beryllium, this is chlorine, this is chlorine. The shape of the molecule here, the linear. The bond angle between them, 180 degrees, students. This is the BeCl2 shape. This is the carbon dioxide shape. Next molecule, what is the next one? sp3, sp2 hybridization. In the sp2 hybridization, if you are observing, first molecule is BF3. What is the central atom here? The boron. Central atom is boron. Boron group number in the periodic table, 3rd A group element. Group number is 3 valency electrons, 3 valency electrons. So 1, 2, 3. Around the boron, 3 fluorines are there. Fluorine, fluorine, fluorine. Here the fluorine, electron, valency electron overlapping. Just count that hybridization starts with s orbital, s, p1, p2. So what is the hybridization here? sp2 hybridization. sp2 hybridization. In the boron trifluoride, total pairs 3, bond pairs 3, lone pair 0. The shape of the molecule is what? Trigonal planar. Trigonal planar. Next molecule is SO3. In the SO3, what is the central atom? In the SO3 molecule, what is the central atom, students? Sulfur triad. Sulfur is the central atom. Sulfur group number, 6th A group element. 6th A group elements, valency electron 6. 1, 2, 3, 4, 5, 6. Around the sulfur, 3 oxygen atoms are there. The 3 oxygen atoms are existing like this. Now here, this is considered as S, this is P1, this is P2. What is the hybridization now? sp2 hybridization. Total pairs 3, bond pairs 3, lone pair 0. So what is the shape of the molecule? The shape of the molecule is trigonal planar. Here also trigonal planar. So sulfur central atom, double bond O, double bond O, double bond O. Boron trifluoride is the central atom, boron, fluorine, fluorine, fluorine. The shape of the molecule. Once observe the trigonal planar arrangement, how it is existing. Here observe the students the trigonal planar arrangement. Here all the atoms are existing in the same plane only in the molecule. This is boron or sulfur. This is oxygen, oxygen, oxygen. Just imagine this is the double bond, double bond, double bond. All the atoms are existing in the same plane. Here the sulfur trioxide, all the atoms are existing in the same plane. Boron trifluoride, all the atoms are existing in the same plane. Trigonal planar. Planar means all the atoms in that molecule existing in the same plane. What is the bond angle here? Here the bond angle 120 degrees in the boron trifluoride. Here the bond angle is 120 degrees. Here the bond angle is 120 degrees, 120. So this is the planar molecule. Planar means all the atoms existing in the same plane. All the atoms existing in same plane. Next sp3 hybridization. So for sp3 hybridization, the best example is CH4. Carbon is the central atom. Carbon valency 4. 4 valency electrons. 1, 2, 3, 4. Around the carbon 4 hydrogens are there. The 4 hydrogens are overlapping with 4 valency electrons of carbon. Hydrogen electrons. So what is the hybridization here? S, P1, P2, P3. So hybridization is sp3. Total pairs 4, bond pairs 4, lone pair 0. In that condition, the shape of the molecule is what? Tetrahedral. Tetrahedral. Tetrahedral means the 4 hydrogens are existing around the carbon like this. I will show the molecule. Just wait, students. Next, ammonia. Central atom is nitrogen. Nitrogen group number 5. Valency electrons 5. 5 valency electrons of nitrogen I am writing like this. Around the nitrogen 3 hydrogens are present. Each hydrogen electron overlap with nitrogen electron. Now one lone pair. Total pairs how many here? The 4. Bond pairs 3. These are the bond pairs. These are the total pairs. Lone pair how many? 1. In this condition the shape of the molecule is pyramidal. The shape of the molecule is what? Pyramidal. Next H2O. Pyramidal means hydrogen, 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 like Egypt pyramids, nitrogen existing on above, the one lone pair. On the nitrogen, one lone pair. Next to H2O, central atom is what? Oxygen. Oxygen group number 6A group elements. 6 valency electrons. 1, 2, 3, 4, 5, 6. Around the oxygen, 2 hydrogens are there. Each hydrogen overlap with each electron. Now here overall how many pairs? 4. Bond pairs 2. Lone pair 2. In this condition the shape of the molecule angular. So angular shape how it is existing? H. On the oxygen 2 lone pairs are present. Once look at the students molecules. Tetrahedral here. Methane. Ammonia molecule is existing like a Egypt pyramids. How they are existing, how they are look like Egypt pyramid shape. This is ammonia molecule, just imagine. Next angular shape. Angular water molecule is existing like a angular shape. This is imagine angular shape. Just observe here. This is the methane molecule. Methane. Around the methane 4 hydrogens are existing with 4 corner atoms, 4 corners. Here this is the methane molecule, students. Methane. What is the bond angle between them? What is the bond angle between them? And what is the bond angle here? the bond angle. In the tetrahedral molecules, the bond angle is 109 degrees 28 minutes. Here the bond angle 109 degrees 28 minutes in the methane. Next, ammonia. Here that this is the nitrogen, 3 hydrogens are existing like this. Here the bond angle is 107 degrees. Here the bond angle is 107 degrees. If you are observed here, nitrogen existing in one plane, the remaining are existing in another plane. Here all the atoms are in different planes. Here the atoms are existing in the different plane. Next, water molecule, if you are observing, this is the angular shape. The angular shape is existing like this. Angular shape, bend shape. Another name is bend shape. Here the bond angle is 104 degrees. 104 degrees existing in the water molecule. On the carbon atom, 2 lone pairs are present. This is also planar molecule. Planar molecule means atoms are existing in the same plane. So this is the hybridization in the case of methane, NH3, H2O, the shape of the molecules. Okay students, next video I will explain you with more different examples.